So this is the third and the final video um, for um, for this problem where we talk about be given an array of A of integers and you're asked to find two integers that sum up to value S. So again, just repeating the examples here in case you didn't see the other videos. So here you're given this array, you would want to find say 10. So basically you're given this array and you're asked to find a pair that sums up to value 20. You eyeball this array, you see that okay, there is a pair that meets the criteria. Now, if you look at this array here, you're asked to find a pair that sums up to 8. You look through this array, you can see that okay, there is a pair that meets the requirement. We talked about a few approaches. So in the last video, we talked about last two videos we talked about approach 1 and approach 2. This video we're going to talk about approach 3, which is where we use a hash table. Depending on the implementation, you can get a really, if you have an efficient implementation, you can get a big O1 lookup time. And the space complexity, I'm sorry, this is actually big O n. And the space complexity is big O n. So let's go through the algorithm here. So it's pretty simple. The idea is that you would so there's no sorting involved here. What you do, you start with you look at the first element, and you would compute the difference. So in this case, it's 10, and then you would look up in the hash table to see, okay, do you have a 10? If it's found, then you would actually exit out right away. If not, you would push this number into the hash table. So the hash table would have 10. Now, and if you go, you update this pointer, and you'd look at the next element. Okay, and then you would compute the diff. 20 minus 2 is 18. Okay, do I have 18 in the hash table? I do not. So what I would then push 2 into the hash table. Then I go to 4. I look at the difference, 16. Okay, do I have 16? No, I do not. So I push 4. Then I update the pointer to 25. Okay, 20 minus 25 is minus 5. I do not have minus 5 in the hash table, so I push 25. Then I go here to 10, and I look 20 minus 10. Do I have a 10? Oh yes, I do. So then you would return that okay, your array meets the criteria, which is and then you would basically just print out the indices of the values that help you meet that help you get the sum of 20. So that's the idea, and here is the code. Here's the pseudocode that helps you get that. So I call it can sum to target. So again, I have an integer array A and S. Let's see, I have a temporary variable n, which is a.count. This is the number of elements in the array A. So what I do is now let me also have a temporary variable x. Okay, so I would iterate through this array, and I go from 0 to n. This is n minus 1, not n. I would say, let's say x is, you compute the difference, which is s minus a of I then I'd do a lookup if so I would have a hash table. So now so I'm just going to put in a have a class, a hash table. Let's call it H here. Assign new hash table. Okay, and then I do H dot. I call it find X not equals null. Then I found the answer, which is print. So I print I, and let's say the hash table. Let me put it this way. So yeah, in this case, I'll just simplify. I could say print found or meet the criteria, and then you would return. Else, what you would do is I would insert X into the hash table, and then I would just move on. And if you iterate through this and hit the end of the array and you don't find it, then you just say print no pair. Maybe I'll just call this found pair. Now, it depends on how you implement the hash table. So you could, so in my case, what I want to do is I want to store key value pairs. So the key is the value that I'm going to push, and which is the array value, and the value. So let me put it this way. So this is a key value pair. This is going to be A of I, and this is going to be I, right? So the other option is I can perhaps do something like this. I can say so maybe I can put this in a variable temp, and then I can say found pair, and I can print I comma temp dot value. That'll give me the positions that that I and temp occur. Now at the same time, in order to do that, I need to make sure that I insert it this way, which is insert. I call it insert, so status insert. I pass in the value X, and I also pass in the position that I'm currently on, and that creates a key value pair or some data structure and puts it in the hash table. So that's the idea. So of the three approaches that we talked about, obviously the hash table is the fastest. Again, this depends on making sure you have a efficient big O(n) lookup. But if you look at it from the space complexity perspective, the approach 2 would be preferable. Approach 2 is also computationally better because you don't have to do the binary search. So that is the those are the sets of yes, that's what kind of concludes the various approaches that we can get to. Thanks.